Matt Matherson here with Math Madness. On this show, we will use a little bit of madness and a little bit of mayhem to teach you some fundamental math principles. It's all about making math fun, right? Well, let's get started with answering last week's brain twizzlers. You would think by now I know to get out of their path. Well, anyway, our brain twizzler question was, what was the very first fast food chain here in the United States? Well, that would be White Castle, 1916, Wichita, Kansas. Well, all right, before we get started on today's chat, let's go over a couple of scenarios from our last episode pertaining to food cost and labor cost. What we're about to discuss is called cost to sales ratio. By analyzing these areas, you can spot problem areas before they become cataclysmic ratios. So referring back to our prime cost, we said prime costs were consisted of food cost and labor cost, right? We said we can get food cost by taking our food cost and dividing that by our food sales. Our labor cost can be calculated as taking our labor cost and divide that by total sales. And then finally, our prime cost average can be taken by those two totals and divided by the total sales. We did that last week. If you remember, we had a 60% prime cost average, and we said that was phenomenally well. Well, here's a good time and a great place to introduce the acronym KPI. This simply stands for Key Performance Indicators. These are going to be key metrics that you want to keep an eye on, a very close eye on in our case. Now, these metrics can run the gamut from how long it takes someone to greet a guest, to the average waiting time for a guest to receive their meals, safety, accidents, anything that you think is worth measuring. Whatever it is, though, that you measure, use the SMART approach as well. That's another acronym that stands for specific, measurable, achievable, realistic, and time-bound. In other words, whatever it is that you're measuring, know why you're measuring it and what you're going to do once you receive that information. For example, let's take our Big Daddy's Burger food cost. Let's say in January, we had $20,000 in $20,000 food cost. We had a total of $70,000 sales in food sales. Then in February, we had a food cost of $25,000 and our total sales of $70,000. And finally, for March, the end of the quarter, we had $15,000 in food cost and total sales of $70,000. Okay, well, let's put this into our illustrious cost to sales formula and see what secrets it spills, okay? So here we go. Over here in January, tell you what, let me step over on this side. Over here in January, you can see that again, we had our $20,000 in our food cost. We just divided that by our total sales, which was $70,000 in this particular case. That gave us 29%. Well, in February, you can see what happened here. We rose $5,000 in food cost. So we have $25,000 in food cost, again, $70,000 in total sales. That gave us a whopping 36%, right? And then the last month of the quarter, March, we backed down to a $15,000 food cost. I don't know what we did right there, but we obviously did something right. But our sales is still $70,000, so this gave us 21%. 15,000 divided by 70,000 gave us 21%. Do you see something here when we look at all the total sales for the quarter? They remain flat. No matter what we did with the food cost, our sales remain flat. Not the ideal scenario, right? We'd like to see this month over month go up, obviously. What else can we take away from this? Well, you see here with the 15,000 food cost we had in March, and in January at the beginning of the quarter, we had $20,000 in COGS. Well, we did improve in that metric, right? We went from 21% to 29%. Well, we started from 29%, I should say, and then we finally ended up at 21% at the end of the quarter. And that's something everybody would be very happy about. So these are just a few things that you would want to keep an eye on, that you'd want to follow as you go through your day-to-day life with Big Daddy's Burger. Now,
multiplying mayhem with Mayhem Matt. Yeah. And here's our host of Multiplying Mayhem, Mayhem Matt.
Well, thank you, Hope and Hummingbird Mimi, for that very sublime introduction. I appreciate it so, so much. Welcome to another exciting round of Multiplying Mayhem. I'm your host, Mayhem Matt. Let's get started. Well, today's topic is going to be on the diabolical distribution. Is it easier to multiply first, or is it easier to divide? I don't know. It's up in the air. It's anyone's guess at this point. But that notwithstanding, let's get ready to meet our very first contestants today. All the way from sunny California, we have, anyway, okay, I got the message. Okay, well, you can see right here what we have. We've got this is equal to that, basically, right? So what are we looking at when we've got the 8 and the 3y, all that in parentheses? Well, what should come to your mind is multiplication, right? Via distribution. We've got the 8 to the 3y, don't we? And then we've got 8 to the negative 5. Same thing over here, 9 to the y and 9 to the negative 6. All minus numero uno. 1. That's right. How do we do this? Well, let's get started. I'm going to put on some blindfolds and let's see if we can solve this. Well, getting started here, since this is the hierarchy of operations, everything is equal. We're starting from left to right. Obviously, I know you knew that. I knew that. Just making sure. So what do we have when we multiply 8 times 3y? Ladies and germs, it gives us a whopping 24y. Why? I don't know. Doesn't matter. But now we've got 8 to the negative 5, 8 times negative 5 to be precise, and that's going to give us a negative 40. But, oh my goodness, what's happened after we did the distribution is we lost the parentheses. Gone. Alrighty now, let's see if we can do the same thing over here. We've got 9 times y gives us, you know where we're headed, 9y. Excellente. All right, 9 times a negative 6 gives us it does indeed, a negative 4 minus 1. Well, you know what? Let's go ahead and solve that real quick. Can we do that? Can we take the negative 54 and the negative 1 and get that out of our life? Let's just go ahead and do that really quick. Negative 54 minus negative 1 gives us a negative 55. And I'm going to bring down everything else so we can see what we're working with. Same thing over here, 24y minus 40. This is all equal to this. Well, you know where I'm headed with this. I know we've done this so many times at this point. We got a 9y here. We got a 24y. We want to combine catastrophic events. Let's combine the 9y and the 24y into something you've never, ever seen before. Where was I headed with this? Oh, yes, I was combining like terms. So if we got 9y over here, and it's a positive in this situation, and we want to bring it over here to the left-hand side, what are we doing? That's right, inverse operations to the rescue again. Matt, how do you do it? I don't know, but let's do it. Let's take away 9 over here, getting rid of that. But we've got to do it over here as well, because if I do it on the right-hand side, I got to do it on the left-hand side to keep things in balance. I know, we know Matt's not exactly up on the balancing, but anyway, we're doing it. So we've got 24 minus 9x. And that gives us what? Well, it does give us a whopping 15, doesn't it? It gives us 15y over here. Minus 40. And that is all equal to a negative 55, is it not? It is. Well, looking at this, ladies and germs, what do we got? Well, we know we want to solve for y, don't we? We want to isolate for y. How do we do that? Well, we've got that 40. It's always something is in our way from making that happen, isn't it? So let's get rid of the 40, the negative 40. How do we do that? Well, inverse operations again. I don't know, but it's just the way it is. So let's add the 40 over here. What does that do? Yep, cancels that out. No more 40. No more 40s. No more 40s. Alrighty, so that leaves us with 15y over here, and that is equal to what? Well, what have I not done? See, I'm checking on you. You didn't say it, but let's add the 40 over here as well, right? Well, what does that give us? A negative 55 and a positive 40? Well, it sounds like that's a negative 15 to me. I hope it does to you. So, what are we left with now, my fine fellow friends? Well, we know we want to solve for y. We need to isolate for y. Inverse operations. Excellent idea. The y is being multiplied by the 15, so divide it by the 15. Is that a safe thing? I'm not sure. Anyway, the y is isolated by itself, but I've divided the 15 over here, so I got to do it over here on the right-hand side because Matt's all about balance. We've already had that discussion a couple of times. Well, what's a negative 15 divided by a positive 15? That's right, my good friends. It's going to be a negative numero uno. And that, my friends, is the ball game. Thank you so much for being here on Multiplying Mayhem. I'm your host, Mayhem Matt. We'll see you next time. Well, welcome back to Math Madness. So let's review a little bit. We know what cost to sales ratio means. We now know that we can take a cost and divide it by a sales total, and we get our percentage. In our example, we had $20,000 food cost, $70,000 in food sales. This gave us a 29% food cost. We know we can also use the cost to sales ratio as a way to keep an eye on labor costs in other areas where costs could balloon and become problematic. Well, that's all the time we have on this particular episode today. But before we go, let's do this week's, you know what's coming up, this week's Brain Twizzlers. Alrighty then. Okay, so what do we have here? Well, let me write down these numbers here. What do these numbers represent here in the United States? That's the hint I'm going to give you because this is a little bit quirky, but I think you'll enjoy it once you find the answer. So what does 66,952 represent here in the great old United States? Well, that's all the time we have for here. Thank you so much for joining us here on Math Madness. I'm your host, Matt Matherson. We'll see you next time.